Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jody Saultz.
Thanks, William. Thanks for joining today's Tech presented by KYZEN. We're going to talk a little bit about under wipe frequency and what is the right number. There's several industry experts out there that have estimated that there's as many as 50 to 60% of all the defects come from the stencil printing process. Some believe that number is probably closer to 90, which I don't disagree with. I think it is actually higher than 60%. If the machine is not optimized and running the way it should. Each element of the printing process must be addressed to make sure that every advantage is taken into consideration. Not just one element, but all elements combined equal success. So the primary goal of printing is to print or place an exact amount of material in a precise location. It seems simple, but in most cases, it's where, like I said, where most of the defects come from. Simply align the board to the stencil and press go. However, in most cases, the printing process has become a little bit more than that. In today's world, most of the customers out there, the common practice they use for the printing process is they either use a dry wipe or they'll use a wet wipe with IPA. These are okay to a point, but when you start getting into some of component technologies today, tighter pitch, the apertures are really close together. Typically IPA or dry wipe, that's usually a no-go. And you'll hear me talk about this several times, but most customers, they never change the default settings. So if they buy a printer in today's world, when they get the machine there, they basically load it up with alcohol, or they use the dry wipe, load it with paste, and they never change those default settings. It's very important to change those default settings. And like I said, you're going to hear me talk about that a few times. If you're concerned about yields or cycle times, or if your underside wipe process is wiping every 3 to 5 prints or less, you probably really should consider an engineered solvent. It'll drastically help your performance of the printer and your efficiency. So IPA, that's not the answer. In most cases, IPA is used probably 60% of the time when I walk into a customer's facility. It was a standard electronic solvent until recently. IPA evaporates very quickly. Absolutely, it costs less per gallon than per se an engineered solvent. And in most cases, they say that it's low odor. I think that's a little subjective. I think IPA smells probably worse than most engineered chemistries that's available in the market today. IPA was traditionally used in flux formation years ago as well. So in some cases, it really doesn't dissolve certain paste like an engineered chemistry would. And it's not, machine compatibility is questionable due to the flammability. So other IPA limitations, no clean flux compositions have changed. You can see on this image on the right, this was taken with ultraviolet lighting. You can see where IPA is leaving streaking on the stencil. If you look very close to some of the apertures still have paste down in the apertures, which is going to affect the printing process. IPA can damage the printer rails, certain tooling, and in some cases, when you use IPA and it gets mixed with certain fluxes or certain pastes, it becomes really gooey, and that gooey mess can cause you major issues in the printing process. IPA also dries faster, so you have a high consumption rate. It requires more volume to wet that stencil, and it's not a very good cleaner. IPA also, in most cases, it's going to dry out those apertures, and it's going to not really per se lubricate the bottom of that stencil, so you're going to get poor print release. And the printer companies, the manufacturers of these pieces of equipment, they don't recommend IPA to be used in the equipment. And I think the most important thing on the IPA side is IPA is very flammable. 53 F is flash point of IPA. Those machines are not designed to be explosion proof, so any short or spark or anything that can happen inside of that piece of equipment can cause major fires. And in some cases, I've seen a couple of these machines burn completely to the ground because customers are using IPA. So how can an engineered solvent help you? It can help with solder paste defects, poor gasketing from flux buildup, insufficient pads. It can help increase prints between wipes from 1 to 2 prints to, I've seen in some cases when customers don't change those default settings, like I said, and you go in, use the right chemistry for the underside wipe process, optimize the printer, and in most cases you can double, triple, and sometimes quadruple the amount of prints that you can do before you have to clean with the underside wiping process. And that is huge efficiency wise and throughput wise. Increased number of prints between offline printer cleaning. In some cases, most customers probably clean that stencil every 4 hours if they're using a dry wipe or IPA, because it just gets to the point where they're having so many defects. Using the right engineered chemistry can take that from 4 hours to sometimes 8 to 12 hours before you actually have to clean that stencil offline, which causes downtime and makes the printing process very inefficient. And also, it's going to help more consistent transfer efficiency between prints and wipes. So we talked about this a little bit. These are just some images and some testing that we did with dry wipes versus IPA versus an engineered solvent. And of course, the dry wipe, we use the dry vac sequence, and then a wet vac on both the engineered solvent and the IPA. And once again, if you look at the ultraviolet images, you can see streaking with the dry wipe process. And even with the IPA, you can see some streaking and some paste left in the apertures as well. But with the actual engineered solvent, you can see that the stencil is very clean. There's no paste on the in the apertures, and there's no paste that's been smeared throughout the top of the bottom of the stencil as well. So we basically use the same parameters on these just to get a comparison, but the data doesn't lie. I mean, using an engineered chemistry can drastically improve your printing process. So what is the right number? I say stop guessing, do your work. There's steps to success that you can do to optimize your printing process. That includes, using the right chemistry that works very well with whatever paste you're using. There's a water-based and solvent-based chemistries out there, so it can be covered from both ends. The right delivery system, every printer has a different delivery system out there, but the things to remember, that paper doesn't need to be wet 3 inches across there. You're really only using about 15 to 20 millimeters of that. So whatever delivery system you have, optimize that paper roll and delivery system of the solvents to be about 15 to 20 millimeters across the top of that paper. And using the right paper, and the right chemistry will save you a ton of money. IPA basically, it's fast evaporating, so it takes a ton more IPA to be able to wet that paper versus an engineered chemistry. And using the correct and right paper will also save you money. If you use a cheap paper, the saturation rate for even an engineered chemistry can sometimes be costly. But if you optimize the whole printing process, right chemistry, delivery system, the paper, and of course all the tooling as far as board supports go, and making sure that you're delivering the right amount of solder and to the stencil so you can get proper print process across the stencil. Even if you're doing it manually, you still have to make sure that you're putting the right amount of paste per se on top of the stencil. So that's important to keep track of as well. And once again, like I said, change those default settings. Customers are really wasting a lot of time They're getting tons of defects, and in most cases, they're not seeing those defects, especially if they're not using SPI like they need to be. When they find those issues, it's usually too late. It's at the reflow, end of reflow, and that can be very costly. So, pay attention. Cheaper is not always better, even though alcohol versus an engineered chemistry definitely is cheaper. Using an engineered alcohol or engineered chemistry will definitely save you thousands of dollars. If you have multiple printers, that adds up in a hurry, not to include the cost of rework and inefficiencies from the printing process when the process is out of control. So take some time, do the work. The proof is in the process. Don't just settle for what it is, change those default settings. Use an engineered chemistry, not alcohol, even though it's more expensive. Like I said, you're going to save tons of money. And let SPI be you know, your so-called your referees with solder inspections machines today and the way they communicate back to the printer. Um, Using the solder paste inspection improves the quality and performance of PCBs greatly. So use that SPI to help you make your printing process as efficient as you can, optimizing that printing process, taking all those 60% deficiencies out are going to help and save you thousands of dollars. So really, what is the right number? I say it's up to you. If you just buy a new machine, or even if you have an old machine and it still has default settings in it and you're using alcohol, in most cases, you're going to get 1 to 3 prints before you have to do underside cleaning. And that's very inefficient, especially when you can spend a little bit of time, use the right engineered chemistry, the paper, the delivery system, optimize your process. In most cases, I would say if you're printing now between 3 and 5 prints between cleaning, I would venture to say optimizing your printer, you'll be able to do anywhere from 8 to 15. So take the time, it's a numbers game. Take the time, figure it out, do your homework, optimize your printer, and your printer is going to become more efficient. You're going to figure out that you really can make that printer efficient and get a ton more prints out and double your throughput in most cases. So in conclusion, understand those key elements of the solder paste printing process. Engineered cleaning chemistry, not alcohol. It can improve your frequency by 50 to 80%. Like I said, sometimes you can go from 3 prints with alcohol and using the right chemistry. You can go anywhere from 8 to 10, 12, even up to 15 in some cases. And maintain control of the process. It's where the rework comes from. It's what costs you the most money on the SMT side. And when problems arise, take 5 minutes, do a system check, just do an overall visual look at the machine. 80% of the time, you're going to resolve that problem. And then utilize that SPI. It's going to help determine that frequency of wipes as well. So there's a few questions I want to go through and answer real quick on this topic. First one being, does using different paper rolls save you money? The answer to that is absolutely. Like I said, using an engineered solvent and the right paper is you're going to get a different saturation rate versus using a cheaper paper and alcohol. So even though, like I said, it costs you more money for an engineered solvent, at the end of the day, using the right paper and the right chemistry, you're going to save a ton of money just by optimizing that underside wipe process and using the right tools associated with that. Does the nozzle type affect how the cleaning agent is dispensed to the paper? Every printer out there has a different delivery system. So the most important thing is, you don't need 3 inches of wetting of paper to clean underside wipe uh, on the stencil. Focus on 15 to 20 millimeters, 3/4 of an inch. Focus on that. Doesn't matter what delivery system you have, even if you are using cheaper paper and you're not willing to change it out, still focus on that 3/4 of an inch, that 15 to 20 millimeter wide on the paper. And that's going to have a great impact on reducing costs. And is there a cost savings if you use chemistry in place of IPA? Like I said, IPA is very cheap, but at the end of the day, it's very flammable. Using an engineered solvent, like I said, you're going to probably double, maybe even triple or quadruple the number of prints that you can do before having to wipe the underside of the stencil. So absolutely, there is a cost savings. I just urge you, take the time, set your machine up, and optimize it and save some money. And with that, I'll turn it back over to William. Thank you.
Thanks, Jody. Thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.